Well, hi, and welcome to my shop here. Today is a very important day, rather. It's February 7th, and today is the due date for me to become a grandfather. So anyway, that's what's happening in my life now. What we're going to do here today, provided I don't get a phone call, is attempt an alignment on this radio. Now, this is very different. Yes, I can call this a radio. It's very different from your regular heterodyne set. There is no intermediate stage. There's no IF frequency. There's nothing like that. It's a tuned radio frequency receiver. So the procedures in the book are pretty clear. Involves using a signal generator here, and first I should get this guy turned on. Actually, let's get him on, get him warming up. Good. So it's a simple matter of putting in known frequencies from the signal generator into the tracer, setting this to the proper setting to match the signal that's coming in, making adjustments then to maximize the signal strength by looking at the magic eye here. And that's about it. I think that's about it. And we start with, first of all, RF band A around 200 is what it said. So we'll go there. Okay. Take the output here. Let's see if we're anywhere near 200,000 hertz here. Let's find out in terms of the tuning of this. So I have a kind of a moderate low signal coming in from the signal generator. I want to ground this here. Down. So there's a 1,000 hertz tone heading for this. What do we hear? Oh, wrong frequency by a mile. We need 200 kilohertz here. Okay, here we are. 200 kilohertz. Just one second. This is my playbook. Yes, my old BlackBerry playbook. Charging up because the charger is shot, but I discovered that there's pins here, magnetic pins, that will grab the clip leads, and I can just charge it from a power supply. And what are you using that old tablet for? I use it when I'm listening to shortwave radio. Okay. Well, we should hear it now. Oh, bingo. Excellent. It's right on the money. It's 200 right there. That's fantastic. Let's see, 260 is a typical IF. Let's tune this to 260. Right on the money. It's dead on. And then 455 would be 450, 10. No, that's 20. 455. Let's see, that's 400, 450. 5 per 455. Be right here. The eye. Up there, 459 on there. That's not bad at all. Because look at how wide it's not very sharp. Great. So there's really no need to do any kind of alignment activity on that particular band. Let's try the B band now. Or am I making an assumption here? Maybe sensitivity issues with this. Maybe I should double check. Let's just check it for now anyway. I'll set this at 800. 800. Okay, checking the eye. No eye. No eye appearing. Oh my, that's a new problem. So the eye is not operating. No operation of the eye in RF. Okay, let me, this is... Okay, so I'm reducing the amount of attenuation. In fact, this is up at 10. Tiny amount of eye movement there. Surely to goodness that's not the way it's supposed to be. Now, when we're in RF, does the eye indicates the RF signal strength, I'm pretty sure. It's just following the voltage that's developed in the detector. It was working on the other band, wasn't it? It was working on the other band. I don't have to go back there, I saw it work. It's a 0. Okay, let's investigate that. I'd rather, since the alignment seems to be pretty good so far, it all seems to be working. No reason to carry on with that right now. Let's figure out what's going on with the eye. Actually, what's not going on with the eye. So, I'm going to stop for a sec. I'm going to check the manual and see what it says about the operation of the eye before I go any further, or I'm going to make a boo-boo. Okay, let's take a look at the circuit diagram here together. So we'll start with looking at the eye. Here's the magic eye, and what is driving the eye. So the eye is driven by this grid potential here. Okay, so I've gotten quiet because, so this is the volume control. I don't need to be quiet. That's the volume control, and this is the gain control, and this is the gain selector, or attenuator, I think is a better term for it. So just looking at these for a minute, it's worth looking at. So whatever you touch this probe to is shot onto the grid and is going to come out on the cathode follower line here. It's going to go down through this voltage divider with these very interesting values here. So if you just for interest's sake, if you add all these values up, you get roughly 5.6 K. So as you move the selector down, you are always selecting the remaining resistors. So let's go right down to the bottom. So the bottom, when you select this, you're selecting 0.56 out of 5.6 K. You see the number? It's a 1 to 10, 1 to 1,000, 1 to 10,000 ratio here. Here's the interesting thing. If you select this, you don't get just the 5.1, you also get this. If you add the 5.1 and this, you get 5.6. 5.6 is a simple factor of 5.6K. And it works that way all the way up. So if you select here, you get all these resistors, which add to 560, which of course is a simple factor from 5.6K. So that's a very interesting set of numbers. Never seen that done before. A little bit of cleverness. I'm sure it's not uncommon. I just never noticed it before. Just a little bit of arithmetic there. Okay, getting focused on what we're doing though. We want to understand why the eye works fine when this switch is set to A. It'd be A over here. But when we switch it to B, nothing seems to happen. So we'll start by, again, tracking back from here. Where's the grid signal coming from? So the signal going here is going to be the rectified signal being applied to this diode part of this tube here, AF, RF. So when RF positioned, this is what's happening, and in A, this works. So we get a voltage here. Now, wait a minute now, if we get sound, how can we get sound when it's set to band B, like it's shown here on the schematic? We get no action of the eye, but we get sound. So something is being rectified in band B. Wouldn't that mean that? Wouldn't that mean that? Is there? So the audio, or the RF rather, so this is affecting the signal that's coming out of here. That's really the way to look at it. The output of this, tuned by these two circuits, this one tuning in here and this one tuning in here. The output comes here. What does it matter if you have B or A? How can that make a difference? For instance, if there's a short in here and it was just knocking everything out, we wouldn't hear anything out of the speaker, would we? The only way the signal gets to the speaker, it's on the same line. It's brought down here, detected. The audio is peeled off, sent through the triode and on its way, like so many radios. And the DC remains. How can this possibly work in A but not B? Because the DC is being drained out. No, wait a minute, no. There's all alternating current signal coming through here because of this capacitor. What if this capacitor isn't blocking? And we get B plus leaking right to the grid here. Well, at least leaking to these diodes. I can't imagine it would work. That thing would work at all. Okay, I gotta try this again because I can't see how it can be doing what it's doing. A false observation on my part. False observation. So I think in band A, it's much louder there, right? It's quite a difference. Really, I'm just switching radio bands here. Why would it sound that different? So I think that's part of the hint there too. Oh, I'm not switching bands. I'm switching from A. Come on. So it certainly does sound different when I do the band switch. Let's give it something to chew on here. My finger. That's band B. Eye is working. Oh, the eye is working, for crying out loud. Why did it not show up here? I'm just finding out that this attenuator is a bigger deal than I realized. So in reading the instructions, which is something I never did very thoroughly when I first got this, one of the first stages is you set these and these to get a half response on here. So for instance, to test this signal that's coming, you'd watch the eye. Tune it in. that's not closed enough for this device to work well. No, I don't need to attenuate it more. I need to attenuate it less. Less. Down. So I want to make sure this is somewhere in its range. Now we're ready to use it. So I've been a bad boy. Okay, so part of aligning this thing is also aligning my brain with using it. No doubt about it. Good though. I'm glad I've studied the schematic. I have a much better idea of exactly what's going on with these controls. I kind of thought, naively, that they're all basically just versions of the same thing. It's just volume done in different ways. I should have stopped and thought, can't be like that. Can't be like that. So the attenuator is cutting the signal down between the probe and the first tube. The fine attenuator, I believe, is changing the bias on the first amplifier tube inside here, changing its amplification amount. I believe that's what's going on with that one. And then the volume control is very much like any volume control. It's tapping off the output of the radio detector and sending the result off to the audio amplifier. The audio amplifier is running full tilt, like in most radios. It's wide open. It really depends what you feed into the front end of it. Now, alignment. Well, I really haven't done anything here. I feel like twiddling a few knobs, a few controls. So let's go back to trying that out, because I convinced myself that even though it may be tuned exactly right, it may not be as strong as it could be. So let me investigate that. First we turn these down, set it to 200 as suggested, and dial in 200 on the signal generator, make sure it's there. Now we'll set this properly. What a good guy. Now there's a couple controls to adjust. And let me just see if I can quickly figure that out. No. Okay, don't be scared by the magic eye there staring back at you. Let's see how this is going to work. Great. So it should allow me to be really precise on the. So this is precisely on the 200. My frequency generator here is just a little off. Let's see if I can just change this a bit. That's maybe a little better. Just want to turn this down just a touch. There's no, come to think of it, there's really no precision in the dial on here. I can make it accurate, but so now we'll see when the eye is maxed out. Right there. And we are tuned to just a hair off of 200. Okay, so there's a little bit to get. Oh my gosh, I put this back to 200. Didn't even see the eye change. Okay, let's see what happens. So at 200, the low end of this band A, it's about tuning coils. So back here are the two coils. Luckily, the person who built this had labeled the heck out of the chassis, because once again, the manual is not helpful the way they've arranged the numbering in that. So here we go. We're going to try to max this up. Oh my gosh, I can't turn it. Let's try it. Two-hander. There it goes. Getting bigger. Wow, not much. Yeah, I think I see where it is. You have to turn it a fair bit to see it change. Okay, so that is a slightly different position from when I started. Now I gotta get this on here. Okay, I'm watching the eye now. I think that also just improved a bit. Holy smokes, this is causing the eye to bump around. Why is it moving? Oh, I see. Okay, so my camera is not supposed to move relative to the eye here, but I had the cord under my foot. Let's try again. That's a little bit better. Actually, you know what? I got the cord relieved in the wrong way here. Let me fix this. That might be better. Just want the camera perfectly still while I'm okay, there we go. All set. Watching the eye. I can't see anything happening. Is that because I'm doing the wrong coil? I don't think so. Band A. Okay, let's take it back. Well, that seems to be opening there. It's not much of a peak. The same thing when you tune this, right? Tune it with the front dial. Not much of a peak. So I think right in there. I don't think it's going to go any higher. Okay, we'll leave that there. So we didn't achieve too much. Let's just see. Are we right on? Really close. It's not even the width of the pointer out. So we're fine there. Let's go down to 450. Get it right on. 450. Okay, let's check and see where we are right now. I'm maxing the eye out. Right there. So instead of 450, we're at 444. So that is a little bit off. So now we're doing trimmers. We're doing the variable capacitors. And A, thank you for labeling all this, Mr. Whoever you were. Okay. Watching the eye now. Opening. Opening. Pretty much dead on the money. Wait a minute, how can this be dead on the money? Because I haven't reset this. Duh. I almost. So I want 450. It's not off by much. 449. Can we even see that? Band A. Don't get it wrong. Band A. There we go. Okay. Watching the eye now. Right there. And the other trimmer. The other trimmer's in the back here. Is this one? Getting my screwdriver to settle in. There we go. Is that definitely band A? Yes. Okay. Watching the eye now. Pretty much dead on also. Let's check now. Tuning off. peak is right there. We are again like a hair width off, so it's not going to get any better than that. Is that the entire alignment procedure? No, that's the entire alignment procedure for band B. Now we'll go band A. Now we'll go band B. Band B. Let me just peek at the manual here to see what it says about the frequency they want you to use. That's all. I just want to catch here. 500 and 1450. So it's probably not critical as long as you're towards the end. 500. Okay, 500. Wait. You can hear it, but barely. So that's absolutely no attenuation now. It's just the volume. Oh, interesting. Volume doesn't... Yes, volume is after the detector, in a sense. Yeah. So, volume not affecting that reading. Okay, great observation, Jim. Another big lesson learned here. Because the eye never functioned before, I never paid attention to it. So to tune this guy now, we're at the low end, so we want to fiddle with coils, not the two I did before. Okay. Okay, here we go. Watching the eye. A small peak there. Camera's so wobbly. I don't know. Okay, well that didn't do much. Let's try the other coil now. Band B coil. Yeah, just... There we go. Okay. Watching the eye. It's pretty much tuned right up there. Okay. We'll go up to 1450 is what it said. Okay. Right on 1450. For some reason we can hear the probably 3 times 500 or something like that. There's halfway point, I would say. 1450. Whoops, wrong band. 1450. There's some crummy stuff in there. What did the eye do? I wonder what all those swooshes are, but let's close the eye here. So at 1445, we're just a hair below 1450. And this dial is slightly low. Could that have made any difference? It can't be made any more accurate than that. So, okay. I distinct feeling I can't possibly improve this, but I'm going to try. Let's just turn this down. B. Okay, B. Watching. My screwdriver came out. There. Okay, and then we do the last trimmer. B trimmer. We gotta be very careful because he wrote band B and band A, and at a glance the B in band can be the B in B, the way he wrote it. Okay, watching now. What happened to the camera here? Okay, watching. Oh, we got a little bit of an improvement there. That'd be the spot, but we're talking about micro improvements. Whoops. And I think that's it for the alignment process. It does you to go back and forth, of course, but these adjustments were so minor there's no need to go back and forth. That's it. She's done. All finished. Well, I don't have my nice loop antenna here, but what do I have that might suffice? Well, we'll just stick it on an outdoor lead. Turn down the volume. Now I'm smarter with using this too. Okay, I don't think we're going to hear any radio stuff, but let's give it a try. Band B. Just a heck of a lot of noise. Now what if I ground the... Let's try this. Wow, doesn't that make a difference? There's a reason for that. Wow, it still goes quiet. Okay, yeah, what I'm doing is a little bit of nonsense here. Let's do this a better way. Oh, I think we gotta go. Yeah, this is good. Antenna, ground. That's interesting. Very, very quiet. Just bear with me for a minute. I'm going to get rid of that extra screen that's up there. Just hang on one moment. And say goodbye to it. Sounds distinctly different. This sounds like a radio up here. Listen how it looks. The volume just really increases. This turns into nothing. What's happening right there? Okay, off the antenna. Why would it be so much stronger up at the higher end? Now, unlike the AM band is a difficult radio band because it's going by a factor of 3, right? You're starting at 500 and ending up at 1500. That's 3 times the frequency here. So this is a really broad sweep through a range of frequencies. I don't know if that constitutes a problem. I don't know. Okay, one more thing we should do. We should plug this guy into a regular outlet and then check the chassis potential on it. And then I think we're done. To remember from now on to turn this control when I switch it on to turn it all the way to the top to start. Okay. This is a regular grounded outlet here, or power bar from a grounded outlet. It doesn't actually have an indicator light, does it? Gonna have to wait for the magic eye to come on. Okay, and let's check for voltage first, very crudely. Okay, so nothing. It's lighting it up slightly. Okay, we'll reverse the plug. A very weak response there. Takes almost no electricity to light one of these things. I'm holding the other prong in my finger in case you're wondering how I'm doing this. And with a little bit of a little bit brighter, but nowhere near full. I got a couple ideas here to try. So we're going to try this with the voltmeter. Actually try reading it. Okay. Let's fool around a little bit here. 200 volts AC. Okay, well, we're going to just 104 volts. Let me reverse the plug. Now that could be 104 volts if I put a regular a non-digital voltmeter and we see 0 at the same time. Okay, what do we get this time? Not the happiest. That's not the happiest result. Kind of figure when you flip the plug around, you should see, the two readings should sum to about 120. Typically, you see around half 120. You see around 60 volts. Quite typically. So, is this really a concern? Let me touch my. If I can get there. So this is grounding this lead now onto my capacitor checker. I'll reverse the plug here. This reversing of the plug should have a pretty minimal effect, I think, on this unit. Okay, grounding it. Same sort of thing, 11 volts. Not going to feel that. Look, I get 10 volts on this meter just testing the air. So even though you're getting a reading, doesn't mean there's necessarily anything behind it of any significance. He says, so why don't we try that? We'll take my warning light here. Okay, and just ground it on the chassis like that. This is grounded to my capacitor checker. We'll see, it's lighting up there. You know what? That's the kind of thing that would give you a tingle, I'm pretty sure. Now, why did I read that? I read, what did I read there? Just do it again. Do it again. The same thing that's lighting up that. Oh my gosh, 105 volts. Oh, look, I'm 15 now. So what am I doing with this test lead here? I'm not making a real cabinet type connection. There's to the cabinet. Yowza! Okay, let me flip that plug around because I think I have it in the less desirable way. Didn't I say this shouldn't make any difference? I think I did say that. Well, that's a lot better. It's the same kind of result we got before. Well, I like 44 better than 100 and something. Do I dare test it now with my hands? Let's see. By the volume of my screen, we can judge how much voltage is there. No, I'm not going to do that. I'm not going to do that. So probably in the end, once I have my test equipment in a suitable condition, I will run a ground bus and ground out all these chassis together to remove this touch potential, regardless of how small it might actually be. So I think what I need now is I really need a radio to fix. I need a radio to fix up. So I can use my brand new, oh so cool signal tracer, which I believe is working at essentially 100% now. I don't think there's anything seriously off about it, except this. Now it's off. So thanks a lot for watching. I do not have, well, I have my own radios to work on, but I don't want to. I think I'm going to continue on the test equipment parade, and we'll just kind of move around the shop here. The next thing to poke around with more would be this guy over here, which you can't quite see. I use this guy a lot. I've had him apart before. I have him apart again, and we'll take a closer look. I don't think I've done any part changes in it. And so we can look at also correcting the accuracy of this if we can. I think that's where we're going next. But who knows? Tomorrow is another day, and I may well wake up and say, let's do something else. Okay, thanks a lot for watching. Onward.